So, hi everyone, this is Jay, your instructor for computer networks. And in today's session, we will discuss what is flow control. So, let's start. You can see that two devices A and B are connected via link. Suppose A is sending data at 10 Mbps and B is receiving data at only 2 Mbps. You can clearly understand that rate of sending data of A is very high than the receiving rate of B. So most of the data which is sent by A will be lost at receiver B and only small portion will be received. So that is problematic, right? In the internet there are lots of devices are connected and they are having different sending and receiving rate. So if server is sending data in on rate, so in that case there will be a miscommunication and it will create a problem in the network. So what we can do in this example is that sender can send data at rate at which receiver can easily receive. For example, if sender is sending data at 2 Mbps, in that case there won't be any problem, right? So that thing is known as flow control. That sender should be sending data at which receiver can receive. Now let's see the types of the flow control. The flow control is divided into two main types. The first one is for noiseless channel and for noisy channel. For noiseless channel, it is having two types, which is simplest protocol and stop and wait protocol. For the noisy channel, it has two types. The first one is stop and wait ARQ and sliding window. And you can see that sliding window is further divided into two categories, go back and selective repeat. Let's start our discussion with the first one, which is for noiseless channel. So the first type of the noiseless channel is simplex protocol. You can see that two devices A and B are connected and A is sending message to B. Now simplex protocol means that communication is only in one direction. So A will only send the message and B will receive the message. So A will send the packet 0, B will receive packet 0. After waiting for some time, A will again send the next packet, packet 1, B will receive packet 1, A will send packet 2 and B will receive the packet 2. So for the whole time, A is assuming that whatever the data sent by itself is received by B. But that is not true, right? Because there is a possibility that B might be busy or B is not able to receive some packet. So in that case, B is not able to inform the sender that I have not received that packet. So whatever packet lost is lost at device B. So that is considered as the major drawback in the simplest protocol. So that is overcome in the next protocol, which is known as stop and wait. Again, two devices A and B. A has sent the message packet 0 and B has received the packet 0. Now the stop and wait protocol is bidirectional protocol. It means that after receiving the packet, the receiver will inform the packet that I have received packet. And how it will inform? It will inform using the acknowledgement. So B has received the packet 0, it will send the acknowledgement to A. So A will receive the acknowledgement. So from the acknowledgement, A will think that okay, the packet 0 which was sent by me is received by B successfully and now B is expecting the next packet. So A will send the next packet, which is packet 1. B will receive the packet 1, it will send the acknowledgement. After receiving the acknowledgement, A will send the packet 2. B will receive the packet 2 and it will send the acknowledgement. So in this whole process, after sending the packet, sender is waiting for the acknowledgement. So after sending the packet, A will stop and wait for acknowledgement, and that is why it is known as stop and wait protocol. In this example, we are assuming that the channel is noiseless. Means that whatever the packet which is sent by A will be received by B. And whatever the acknowledgement which is sent by B will be received by A because there is no noise in the channel. But that is not the case in the practical scenarios because channel will be always noisy. So let's see what happens when the channel is noisy. So let's see, again we are taking the same example, but the only difference is that the channel is noisy. So A has sent the packet 0 and B will receive the packet 0. Because it is stop and wait, so B will send the acknowledgement. So A will receive the acknowledgement. So from the acknowledgement, A will know that okay, packet 0 is received. So now I will send the packet 1. So A will send the packet 1. B will receive the packet 1. It will send the acknowledgement for the packet 1. So when A receives the acknowledgement, it knows that packet 1 is received successfully by B. Now I have to send the packet 2. So A has sent the packet 2. But because of the channel is noisy, packet 2 is lost somewhere. Now what happens in this case? A has received the acknowledgement for the packet 1, so it has sent the packet 2. B has sent the acknowledgement for the packet 1, so it is now expecting the packet 2. But because the packet 2 is lost somewhere, B will continuously wait for packet 2. Now A also doesn't know that its own packet is lost in the channel. So A will wait for the acknowledgement for packet 2. So in this case, A is continuously waiting for acknowledgement and B is continuously waiting for packet 2, and they both are waiting for infinite time, and it is now deadlock. So it is a problem, right? Because no communication can be done any further. Suppose what happens if acknowledgement is lost. So let's take the same situation that A has sent the packet 0, then B has received the packet 0. Because it is stop and wait, so B will send the acknowledgement. When A receives the acknowledgement, from that it will know that packet 0 is received successfully. Now it's turn to send the packet 1. It has sent the packet 1. B has received the packet 1 and B has sent the acknowledgement. Now this acknowledgement is lost in the channel. Now you can clearly understand that B doesn't know that its acknowledgement is lost. So B is waiting for packet 2 because it is expecting that okay, I have sent the acknowledgement, so now A will send the packet 2, and A is waiting for acknowledgement because A knows that it has sent the packet 1, so it is waiting for acknowledgement so that it can send the next packet. So both devices now in the infinite waiting time, and there is a problem in the communication. So how we can solve this problem? This problem is solved in the stop and wait ARQ. ARQ stands for automatic repeat request. So we are taking the same example that A has sent the packet 0 and B has received the packet 0. After receiving the packet 0, B has sent the acknowledgement, and the acknowledgement is ACK1. From the ACK1, A will know that okay, packet 1 is received successfully. Now the B is expecting the packet 1. Always remember, the acknowledgement is always greater 1 than the sequence number of the packet. So for the packet 0, acknowledgement number is 1. But as you can see that packet 1 is lost in the link. So because of the packet 1 is lost in the link, B will continuously wait for the packet 1 because it has sent the ACK1, and A will wait for the ACK2 because it has sent the packet 1. Neither two of the devices knows that the packet is lost somewhere in the channel. So to solve this problem, A will use the timer, and that timer is known as timeout time. So after sending any packet, sender will wait for some fixed amount of time, and after waiting for fixed amount of time, A will send the packet again. For example, A is waiting for 5 seconds after sending the packet 1. So after 5 seconds, if ACK2 is not received, A will send the packet 1 again. So B will receive the packet 1, then it will send the ACK2, then A will receive the ACK2, from the SCK2 it knows that packet 1 is received and it has to send the packet 2. So it will send the packet 2. Again, packet 2 will be received by device B and it will send the SCK. So you can see that the infinite waiting problem is solved using the automatic repeat request. Now, what happens if the acknowledgement is lost? So A has sent the packet 0, B has received the packet 0. We know that for the packet 0, it will send the acknowledgement 1, which is 1 greater than the sequence number of packet 0. A will receive the acknowledgement 1, so it will send the packet 1, and B has sent the ACK2. Suppose acknowledgement 2 is lost somewhere. Now you can clearly understand that A is waiting for acknowledgement 2 because it has sent the packet 1, and B is waiting for packet 2 because it has sent the acknowledgement 2. So in this case, again A will use the timer. So after sending the packet 1, it will use the timer for some fixed amount of time, let's say for 5 seconds. So after sending packet 1, it will wait for 5 seconds. If no acknowledgement is received, it will send the packet 1 again. So B will receive the packet 1. Now B has received the packet 1 again, so it will delete the duplicate and it will keep the new one and it will send the ACK2. A will receive the acknowledgement 2, so it will send the packet 2. B will receive the packet 2 and it will send the ACK3. So in the stop and wait ARQ, after sending every packet, A will use the timer. The sender will use the timer. And after the fixed amount of time, if sender is not getting any acknowledgement, it means that it will send the packet again. Now, what happens if the received packet contains some error? What I'm trying to say is, packet is sent by sender and receiver has received the packet, but the received packet contains some error. So what happens in that case? So A has sent the packet 0, B has received the packet 0, it will send the acknowledgement 1. So A has received the acknowledgement 1, so it will send the which packet? Packet 1. So A will send the packet 1, B will receive the packet 1, and suppose that packet 1 is found corrupt. So when corrupted packet is found, B will send the negative acknowledgement instead of acknowledgement. When the sender receives the negative acknowledgement, it knows that the receiver has received the packet successfully, but the packet is corrupted. So A will send the packet again. So you can see that packet 1 is sent, packet 1 has sent again by A, and B will send the ACK2. Now let's discuss the pros and the cons of the stop and wait. The stop and wait is the easiest and the simple method. And after sending every time, the sender is waiting for the acknowledgement. And we have also seen that it can be also used for the noisy channel, because if acknowledgement is lost or packet is lost or packet is received corrupt, there is a way that we can still communicate. But what is the disadvantage? That this method is very slow. At a time, we can send only one packet, and after sending one packet, we are waiting for acknowledgement. Now imagine if receiver is very slow and after receiving it is taking large amount of time to acknowledgement that packet. So in that case, the communication will be very slow and it will be very inefficient. So that problem can be solved using the pipeline method. So in the pipeline protocol, we will send more than one packet at a time. And how we can do that we are going to see in the next lecture. This is it for today's session, and if you have any doubt, you can ask me in the comment section. Thank you so much.